All right, guys, here's some support on question number 10. So I actually did some extra supports on this that you guys can use, but I want to give you guys a short example that you guys can follow, okay? So for this question, guys, it says express in the simplest radical form, all right? So a radical is a square root. So again, a radical is a square root, okay? So when I'm saying I'm trying to simplify the radical, that means I'm essentially trying to simplify the square root, okay? So for this question, guys, I see a square root at the numerator, but I do not see one at the denominator, okay? So that means I have to simplify this square root first before I can even do anything with the denominator, all right? So let's try to simplify the square root of 12, okay? So in simplifying this, guys, I'm going to use a method called prime factorization, all right? In the other video, I showed another method that you guys can use, but prime factorization is the fastest and probably the most efficient way, all right? So with prime factorization, you need to first list the first 5 prime numbers, all right? For you to be a prime number, you have to be divisible by only yourself and 1, all right? So first 5 prime numbers are 2, 3, 5, 7, and 11. 1 is not a prime number because again, 1 is itself. All right. So 1 cannot be divided by itself and 1 because 1 is itself. All right. And then the next prime number after 11 would have been 13, then 17, then 19, and so on. All right. They're not all odd numbers because as you can see, 2 is not an odd number. All right. So 12, you're going to ask yourself, can I divide 12 by any of these prime numbers? Can I divide by 11? No. 7? No. 5? No. 3? Yes. Okay. And when I divide 12 by 3, I have a remainder of 4. You put your remainder on the right side. Now I'm going to try to divide my remainder. All right. So can I divide 4 by 3? No. By 2? Yes. All right. And I have a remainder of 2, which none of these can be simplified anymore. All right. So we have prime factorized this. Okay. So now we're going to circle our pairs. All right. So that means I have, whenever you have pairs, that means that that number is going to be on the outside of your square root, on the outside of your radical. All right. The thing that does not have a pair, the number that does not have a pair, you put a box around it because that number is going to go underneath your radical or underneath your square root. All right. So 12 is the same as 2 square root of 3. All right. And that's all over 6. Okay. So now I need to simplify because both 2 and 6 are divisible by 2. All right. So 2 divided by 2 leaves me with 1, and I rewrite my square root of 3. And 6 divided by 2 leaves me with 3, and this would be my answer. All right. So again, guys, that is how you will be able to do this question. Okay. So 1 square root of 3 all over 3. Up, all over 3. All right. So again, guys, let's practice another one. So let's try another one. Okay. So here we have a square root of 12 and a square root of 2. But because both of them have a square root, that makes them like terms. All right. So the same way if you had 6x and then you have a 2x, you would divide this to get 3 because the x's cancel each other out. The same thing applies with square roots. All right. So again, I can divide square root of 12 by square root of 2, and I would get square root of 6. Okay? So now we're going to try to prime factorize it to see if we can simplify it anymore. So the first 5 prime numbers are 2, 3, 5, 7, and 11. Can I divide 6 by 5? No. By 3? Yes. All right? With a remainder of 2. But if you realize we have no pairs, so that means that square root of 6 cannot be simplified anymore. All right. So my answer would be square root 6 because again, it cannot be simplified anymore. There were no pairs. Okay. So again, guys, let's try one last one, guys. I know I only required one, but this has a lot of different variations. All right. If you want to see all the variations, watch the next video. Okay. So these both have square roots, so that means they're like terms. I don't see an addition sign or subtraction sign in between them, so I automatically assume I'm multiplying. Okay. So multiplying square root of 10 by square root of 50, I get square root of 100, or sorry, square root of 500. Sorry. All right. So now we're gonna go ahead and try to simplify the square root of 500. Okay. So I list out my first five prime numbers. Okay. And then can I divide 500 by 11? No. 7? No. 5? Yes. All right. And then I get 100 when I divide 500 by 5. Okay. Can I divide 100 by 11? No. 7? No. 5? Yes. Okay. And I get 20. Can I divide 20 by 11? No. 7? No. 5? Yes. And I get 4. And I can divide 4 by not 3, but 2. And I get a remainder of 2. So I'm going to circle my pairs. So I have one pair of 5. So that means I have a 5 on the outside. And I have one pair of 2s. So that means I have a 2 on the outside, and they're being multiplied by each other. Okay? I have a singular 5. So that means I have a singular 5 underneath my square root. All right? So when I multiply 5 and 2, I get 10, and then the square root of 5 stays the same. All right. So again, guys, that would be the result. Okay. So watch my next video if you want to see all the other different variations.